So, here is a question in which it is given that a beam AB is there which is simply supported beam having a span length of 5 meter as well as a point load of 20 kilonewton is acting at the center of the beam. That means we can say it is point A, this is B, this point is our C. That means 20 kilonewton acting at the center. That means from A to C is equals to C to B, which is our 2.5 meter. And here we can see the portion from A to C and from C to B, both the sides are symmetric. So it will be very easy to solve the problem. So first of all, we have to remove the support and we have to put the support reactions. Here, we'll draw the beam again. Here is having our hinge. In hinge, we have two reaction forces as well as in our roller, we are having one reaction force. This is our reaction at, this is our VA and this is our HA. Instead of roller, we will put one vertical reaction which is our VB. The length is 5 meter. The point load is acting, what is the value? 20 kilonewton. 20 kilonewton from 2.5 meter both the sides. Okay. Then we have to put the equation of equilibrium here. First, summation of all the forces along x-axis is equals to 0. Here we have only one forces which is our horizontal force, that is HA. Apart from HA, we don't have any other horizontal reactions. So here we can write HA is equals to 0 directly because we don't have any other horizontal forces. When you will, in the case where the load is not acting, when the load is applied to a beam at an angle, then the cos component and sine component will be resolved. At that time only you will get the horizontal reaction. If the load is acting perpendicularly to the plane, at that time no horizontal reactions will be generated. Okay. Then the second one is our summation of all the forces along y-axis is equals to 0. Here we can see VA is our horizontal reaction, VB is our horizontal reaction, VA is our vertical reaction, VB is a vertical reaction, as well as 20 kilonewton force which is acting downward is a vertical reaction. These two forces are in upward direction and the 20 kilonewton force is downward direction. So we can write, we have to take the sign convention, we can take as our choice. If I am taking the upward forces as positive and the downward, then I have to take the downward forces as negative, if or vice versa. Okay. So I am taking the upward forces as positive and the downward forces as negative. So we can write VA plus VB. These are the upward forces, that's why I have positive sign, and it is the downward forces, I will take it as negative. Minus 20 kilonewton is equals to 0. That implies VA plus VB is equals to 20. This is your first equation. Next, in equation of equilibrium, the third equation is that summation of movement at any point is equals to 0. So we can take summation of movement at A equals to 0, or we can take summation of movement at point B equals to 0. In any point we can take the movement is equals to 0. So I am taking summation of movement at point A equals to 0. So then we have to write the moment equation. Here you can see the formula of movement is equals to movement is equals to force multiplied by perpendicular distance. Okay. So whenever we are calculating the movement at this point, due to this force, one movement will be generated. Due to this force, one movement is also will be generated. But due to VA, particularly for VA, no movement will be generated because this reaction force is acting along the point. So there is no perpendicular distance between VA and point A. That's why no movement will be generated. So before going to the movement, we can take the clockwise movement as positive and anti-clockwise movement as negative, or vice versa. Here we can see the VB force, reaction force, when will generate a movement around A, it will go like this. It will go like this, which is our anti-clockwise direction. So we can write minus VB multiplied by the perpendicular distance is between VB and A is 5 meter. 5. Then it is the 20 kilonewton force. Due to the 20 kilonewton force, movement will also be generated, but the force is in the downward direction. So if this force wants to generate a movement at point A, then it will go in this direction, which is our clockwise direction. Understood? Then I am taking anti-clockwise movement as negative, then only I will take the clockwise movement as positive. So plus 20 multiplied by the distance is, the distance from 20 kilonewton to point A is 2.5 meters. 2.5. Then coming to the point A, where the reaction force is VA. It is the reaction force which is VA. As I have told before, VA is passing through the point A. So there is no perpendicular distance between VA and point A. If you will write it, then it will show minus VA multiplied. How much is the distance? The distance is 0. The whole term will be 0, is equals to 0, because this is the equation. So we can write the equation like, that implies minus 5 VB is equals to minus, I am taking the value to the right hand side, equals to 50. So that implies VB is how much? Minus minus cancel. VB is our 10 kilonewton. Understood? Then by putting the value of VB in equation number 1, VA plus VB is equals to 20. That means VA is equals to 20 minus VB, which is equals to 20 minus 10 is equals to 10 kilonewton. As I have told before, it is a symmetric section. So from directly, as I have told before, it is a symmetric section. That means the portion from A to C is similar to C to B, and 20 kilonewton force is acting. By applying the logic, if a upward force is there which is having 20 kilonewton and two reaction forces are there, one at A and another at B, and the structure is stable, that means both the reaction forces are taking the same load. That's why the structure is stable. So that means if it is 20 and both the forces are contributing same effort to make the structure stable, then obviously point A reaction will carry 10 kilonewton as well as point B also carry 10 kilonewton. So it is a symmetric section. Okay. Next we will do the problems when the loading point load is applied to a beam when it is not acting on the center, having some distance from the left hand side or from the right hand side. In the next lecture, we will discuss about that. Okay, thank you.